Hello and welcome to SudoKanard. We're here to solve this odd-even Sudoku or even-odd Sudoku by Thomas Snyder from the United States of America in round 8 of WPF Sudoku Grand Prix of 2022. So the special rule is that every shaded circle, gray circle, must contain an odd digit, and every square must contain an even digit. And you must see that those draw a figure 8, which is interesting considering it was round 8 and puzzle 8. But actually there was a real, a real style, a real theme, a visual theme around digit 8 throughout the contest. So 42 points, that was quite a lot for such a puzzle, but I seem to remember that the odd digits needed a little work to sort out. I remember also having to restart the puzzle because of some mistakes. All right, so these must be 6 and 8, and this is not 6, that's 8 and 6. So this is from 2 and 8. And actually, if you look at this row, we have odd, 3 odds, and this must be odd. So this must be even. That's the second 2 or 8 in the row. This can only be a 4 now. And the remaining cells here must be odd. Which means that in this box, the even digits must be in the remaining 3 cells, and actually 6 can only be here by Sudoku, 2 must be here, and 8 must be here. Here we have 1, 5, and 7. I'm not sure it's interesting to pencil mark them. Let's do some Snyder notation, which is sort of funny, I think. Alright, so now we need a 4 somewhere here, but it's not an odd digit, so 4 is here. And we need 2 and 8 in these 2 cells. And those now are odd. So the second 2 or 8 must be something in here, somewhere in here. It's interesting because we already have 2 even digits here. So there are 2 even digits here, another even digit here. So this is odd, meaning that the 4th, no, sorry, I'm mistaken here. Or am I? So this is no more an even digit. So this must be even. Yes. On this row, we know that this is odd, so we have 5 odd digits here. So this one must be even. So that's 2, 4, 8, and this is 2 or 8, and this is also 2, 4, or 8. And this is 2 or 8. All right. So now, on this row, the remaining even digit must be here, and it must be 2 or 8. And we know we have a 6 somewhere here, around here to be precise. So on this column, actually, that's a 4. That's not a 4. And we still need a 6 somewhere, and this is even, so this has to be a 6. All right. So no even digit here. What about this cage? 6 is not in here. 6 is even, so it has to appear here. And those, well, 2 can only be here by Sudoku, and 4 and 8 must be around here. So this can't be 8, so 8 is in one of them. But actually this 2 resolves the 2 8 pairs in here. Still nothing more but 6s. 4, 8 are not in here. That's not 4, 8, so actually we get a 4, 8 pair in those 2 cells. Interesting. So that's even, that's even, and the other two even digits are 2 or 4 here, 2 or 8 there. That's interesting. And 6 must be somewhere around here. And where is the 4th even digit? Somewhere in here. And that's 4 or 8, and I'm not sure about that. Right. I think, is it time to talk about odd digits here? 7 by Sudoku 7 is here, so that's a 6-7 pair. Interesting. So here we have, this can only be a 1, and that's a 3-5 pair. This can only be a 9, and here we have another 3-5 pair. Alright, so this is now 7. So we get a 7 around here, which makes this a 6, that's a 7, and the last 6 is here. I think we have all 6s in the grid. So in this column we still need 3, 5, and 9. So this is 5 or 9. This is 1 or 5. This column, where do we still need to put even digits? That's the question. On this row, we still need to place the 4. On this first row, it could be here, could be somewhere here. On this column, we still need to put the second 4, 8, well, 5 is somewhere in here. I'm probably wrong not putting more pencil marks into this. 3 is down here. 7 is here actually, so this is 1 or 9. And actually 1 is not here, so 1 is here in the column. And we have a 3-9 pair in here, which makes those, I'm not sure about that, that's 4 or 5. Here, that's 4 or 8, because this is 9. This can only be 3 or 5, so we get a 3-5 pair in this column. And this is actually 8, so that's 2, that's 4. Now we need another 2, that's the only place in this column, and that's a 1-9 pair. We still need a 4 somewhere in here. And there are still 2 places. This is from 359. Not interesting. 357 here. Here I need a 1 and a 5. This is 379. So 39, 79, 37. Here that's a 3 or a 9, and that's interesting because I'm having a 3-9 pair, so that's a 7, that's a 3, that's a 9, that's a 3, that's 9, that's 3. All right. 1, 9, and 5 in here. There's a 3 somewhere. 1, 5, 9 here, so, oh, actually there's a 7 here. So this is 1 or 5. True here as well. This is 3 or 5, and I get a 3-5 pair in here. So those are 4, 7, and 9. 9 can only be here, so that's a 7, that's a 4. And it resolves this, 5 here, 3 there, 5, 3, 5, 3. This 4 now makes this an 8, so that's 8, that's 4. That's 4. Here this can only be an 8. This is 105. And finally, well, how's this resolving? 509, this is 509. I need a 3 somewhere. That's not a 3, so 3 is here. This is 105. And those are from 159. And I'm just missing a simple elimination. That's a certainty. But what is this? There's a 1 here, so that's not the 1. Well, that works. And that is certainly a direct elimination, not a special technique. I just wonder what I'm missing. That's a very bobbins format. I'm seeing this. Alright, I use color. I remember seeing this during the contest. So let's use some coloring. Alright, those 1s and 5s. You see that red, green and red. Oh, sorry, for colorblind people, those are not very friendly colors. Let's say green. Green and red should be more friendly. Red and yellow, sorry. So this digit is different from this one, so this digit must be the same as this one. And so this digit and this one are different. So one of them is a 1, one of them is a 5, and as a result, this must be a 9. And this disambiguates the remaining digits. And the fact that such a technique is needed for ending the solve may be the reason why it was worth 42 points. Well, obviously you can always bifurcate in this case and just try something to see what works and what doesn't work. It may be the fastest course, but I remember doing this. This configuration is called a remote pair because we have real 1-5 pairs here and here and here, and this here is a remote 1-5 pair, which means that all digits here and there can't be from 1 and 5. That's a very fancy technique. I like it, and there was a remote 4-5 pair, I think, in a puzzle of mine. It was in round 4 of WPF Sudoku Grand Prix of 2022. It was on a classic Sudoku. Thanks for watching this video, and see you soon on SudoKanard.